Hello, hello. Check it out. This is my yearbook picture. We got them today. That was pretty, pretty funny, a little bit. All right, I wanted to talk more about a box and whisker plot today. Check it out, look up here on the board. What I want you to do is pay attention to the spread on this particular box and whisker plot. The box in the inside right here accounts for 25%, 25%, so it totals, this is the inside 50% of our data. Okay, so box and whisker is just a way to represent the spread. How spread out is it? It's obvious to me right here that this short little whisker on the top means that most of their songs are actually played within this range right here. Okay, so that means it says right here, box and whisker plot represents the length of songs in seconds played by a rock band at a concert. I don't know why they care so much about the length, but somebody's analyzing all of this data and paying attention to it. And people actually get paid big bucks to analyze data for various reasons, especially in scientific communities or scientific research and things like that. So let's check it out. Let's go into a little bit more detail right here. I'll erase that, and then let's take a look. It says right here, find and interpret the range. The range of the data is always maximum subtract the minimum, okay? That one is not that hard. It's not a big deal. Where's the maximum? Right here. Max. Hey, where's the minimum? It's that point right there, minimum. So you just have to read the point underneath of it. So it will obviously be 300 is that number right there. Subtract 160. See how 160 pairs up with that one right there? And so we go 160. And the spread on the data is 140. Okay, 140 seconds from the shortest song to the largest song, to the longest one. Okay, so the next question in our list says, describe the distribution of the data. Okay, there's not a lot of detail right there. It just says describe it. So one way that I would describe the distribution of the data is to say that 25% of the data lies in this region right here, 25%. 25% of the data lives right there. 25% is from here to here, and another 25%. So most of the songs that are played at this rock concert by this band fall within this range right here, kind of that upper limit. So they're a particular band that plays songs that are a little longer, a little windier than some other bands. There are some bands that play 2-minute or less songs, and that's the most of their songs, are 2 minutes or whatever. Some bands play really long ones. So what is 300? 300 seconds would be about, what is that, 5 minutes? Where's my calculator at? I don't know. Something like that. 260 would be about 4.5 minutes. Yeah, that's about right. Somewhere in that range. Okay, so right here it says, describe the data. You would have to write a little sentence or so that would say 25% of the data lives from 160 seconds to 220. Another 1/4 of the data is somewhere between 220 to 260. The median is 260. Or you could do 5 number summary on that question, and you could just describe what's the minimum. This is called quartile 1, and then right here is called quartile 3. All right, let's jump to this next question. This next question says, find and interpret the interquartile range. Interquartile range means the box. What's the range of the box? And so one way that we abbreviate that is we call it the IQR. There are reasons why we want to know the IQR. We want to know the most inside 50% of the data. That's 25% and 25% put together. That's the half of the data, and how close is it to the median? If we have a big box, then that means that the numbers are more spread out. If we have a tiny little box that's short and stubby, that means that the numbers are really close and clumped together. All right, that means there's a band that plays more than half of their songs or so, 50%, half their songs would be really close to the same length. All right, but if they're more spread out, then it means there's more variation on the actual length of songs. Okay, let's calculate the IQR. The IQR can be calculated by taking this upper quartile and the lower quartile and subtract them. So I'm going to write Q3 right there. So this is Q3 and this is Q1. We call this quartile 1 and quartile 3, and all we do is subtract. Okay, so quartile 3 minus quartile 1, because quartile 3 will be larger and we want it to be a positive number. So what is that? That is 280 minus 220. Okay, when we do that we get 60. 60 what? 60 seconds. 60 seconds means that half of the data is within 60 seconds. That's a minute of each other. Okay, so that means that most of the songs lie within that range. Whoa. Wow. Last question. There's a clump of questions here. It says, are the data more spread out below Q1 or above Q3? That means analyze the little whiskers. Are the whiskers long, like a little kitty? This whisker right here is like, whoa, cut that whisker, too long. And then this one's a little stubby, short whisker. That means this one is not spread out. It is really close together. That means they don't have a lot of songs that are really long. They don't have one song in their tool bank that is like, you know, Stairway to Heaven, 7 minutes or whatever. Instead, they're long. They've got a lot of long songs, but they're close together in terms of their length. This means that they don't have as many. They don't have as many short songs. They're not as spread out. But there's at least one song that's in this 160 range, which I think is what? A little more than 2 minutes. 120 would be 2 minutes. So anywhere a little bit above that. Okay. That sounds like we've analyzed a box and whisker plot. So thank you very much, and keep up the hard work. You're doing an awesome job. I know these videos are a little tedious to have to watch and stuff, but this is how we get better and analyze how we're doing things.